Yeah, so hello students. This class is going to cover election algorithms. As in previous class, we have finished mutual exclusion algorithms, and those algorithms are going to represent the structure. Actually, they focus on the mutually exclusive exclusion, or you can say the mutually exclusive participating entities and processes into the distributed systems. That was the main goal of studying mutual exclusion algorithms, how they were participating in the distributed system, right? But now with election algorithms in today's class, what we are going to cover is these algorithms are going to work for a common goal or aim, that is to elect or to choose a coordinator, or you can say the moderator, as you are having the CR for a class. So same way you are going to choose here all the participating nodes, all the participating entities, the processes, they are going to choose one particular coordinator. Okay, and that coordinator or moderator will be coordinating the complete distributed system till it undergoes some kind of failure. Again, that process will be continued uh, when the next coordinator or when the next coordinator will be elected, you can say, right? So in this case, now simple introduction of election algorithms will be the attempt or the goal is to locate the process with the highest process number. This is very very important here because each ever each and every I'll say each and every participating node or process or entity is going to have its own ID, identification number, you can say, or process number. Now, this both algorithms, Boolean and ring, are going to take the process number or ID number of every participating process. Only thing is we have to keep on checking in each and every iteration that which process is having the highest process number or ID. Based on that, at the end, whichever process is left with the highest process number or ID, that particular process or node becomes the coordinator. It will be announced to all the other neighboring or participating nodes that this node has become the new coordinator, or it is elected as a new coordinator. Again, that coordinator will start the process till it undergoes some kind of failure, then next. So this cycle continues till only one node is left in the distributed system. Okay, so this is a continuous process of electing one after another. So the main goal is to locate that particular process or node with the highest process number or ID number and designate or elect it as the coordinator. Obviously, when it is elected as a coordinator, tell all the other active or participating processes about this election and the chosen coordinator, right? Now, to allow a recovered leader to re-establish the control or at least to identify the current leader. Why? When it is required, actually, because when your coordinator is undergoing some kind of failure, fault, or it has crashed, obviously the other connected node or the neighboring node will start the election process. It becomes initiator. In that case, we will study the algorithms in detail. In that case, what that initiator will do, once that election message is called, that election message will be sent to all the nodes which are there in that distributed system. It will be sent to that X contributor, or not contributor, X coordinator also, or you can say X leader also, because just to check again and again whether it has recovered with that from that failure or not. Suppose when the election message is sent to all the participating nodes, or election is called, and that message is sent to the X leader or X coordinator also, which has undergone some failure, but by that time it has recovered from that failure. So that particular X leader can join the election process again. And after joining, obviously, when it is having the highest ID number, it will become coordinator again. So that's why each and every time, whenever election is called, the election message is also sent to the X leader or X coordinator, even if it is crash or not, but just to keep on checking whether it has recovered from that failure. And if it is still under that particular failure, so it will not respond. So other participating nodes will come to know as that X leader or X coordinator is not responding. That means it is still under that failure. So we all will continue with the election. Simple thing, right? So the two algorithms are bully and token ring again. So don't get confused with token ring because it's in here also. In election, it's in mutual exclusion algorithms also. Now, so in Boolean algorithm, you can see there are three messages: election E, which will announce an election; reply R for any kind of reply, response, acknowledgement, election message; and coordinator is C, which will be announced as new coordinator. Fine. So now in Boolean algorithm, just check the four diagrams. Actually, this particular example will not consist of only four. Few algorithms they have assumed into these four, right? So don't get confused. You can just read the statements given here. Process A. Now initially all these nodes are there in the distributed system. You can see 0, 1, 2, 3, 4, 5, 6, right? Now, assuming that initially as 6 is having the highest ID number of process number, 6 is the coordinator. Okay, and the work is properly going on, but 6 undergoes some kind of failure, okay, or fault. So 6 is now the 6 is crashed now. 6 is the failed process. Fine. Now what will happen? The next neighboring node, okay, it will come to know about the 6 process that is not responding at all. So what this 2 will do? 2 will act as an initiator because 2 will start the election now. As 2 is starting the election, 2 is going to send that election message that is capital E, denoted by capital E, to other nodes. But which other nodes? The nodes which are having the highest process number or ID than 2, not 2, 0 and 1, because it knows 0 1 कुछ से कम है. There is no point of sending election message to them. वो picture में आएंगे ही नहीं. So what 2 will do? 2 will send the election message E as an initiator to the process nodes which are having the highest or higher process numbers or ID than 2. So you can see the election message goes to 3, 4, 5, 6. 6 will be also receiving it, but 6 will not respond because 6 is still in the failure mode. If still 6 has overcome that failure mode or it has recovered that failure mode, then it will come back and will join the election. But here in this diagram, 6 is still in the failure mode. So what 2 will do? 2 will come to know 6 is not responding. Okay, 5, 4, 3 will also come to know they are not responding. So what 5 and 4 will do? 5 and 4 will tell 3 that now from here we are going to take over the election process. So you have become bully now, you will be killed. So 3 is gone away from the picture. Now 4 and 5 are there in the picture. Okay, as 4 and 5 are there in the picture, again election message will be sent by 4 to 5 and 6. जो कम है वो भेजेगा ना, तो by 4 to 5 and 6. Again 6 will not respond because it is in failure state. So what 4 will come to know? As 6 is not responding, only 4 and 5 are there, right? So what 5 will do now? As only 4 is there, so 5 will make the 4 as bully. It will say that I am going to take the charge over now from here. So now 4 will be killed, kept it aside. Only 5 is left. Again 5 will send that election message to whom now? Only one process which is having the highest process number or ID than 5, that is 6. So 5 will send that election message to 6. Again 6 will not respond because 6 is failed node only still, right? So 5 will come to know as 6 is not responding, I am the only left one now, so I am the new coordinator of this distributed system. So it will announce that it is the new coordinator for this entire distributed system, and that C message of coordinatorship, new coordinator, will go to all the other participating neighboring nodes. So this is Bully algorithm. So whichever node is with a lower process number or ID number among the chosen one, that will be bullied, okay, and it will be kept aside or killed, you can say. So that is a Bully election algorithm for choosing the coordinator. Now talking about the token ring, you can say in token ring only two messages E and C, because there is no point of reply, because you can see the earlier diagram we are taking replies also. Okay, that's why our message was there, right? What is the reply? That each and every process IDs and numbers will be taken here. Whoever is going to initiate the process, and from there it will come to know कि किसका process number ID बड़ा है. In that case, the other one will be with the lower process number or ID will be bullied, right? But in token ring, what will happen as it is going to move in a cyclic structure or ring structure, you can see that there is no kind of reply possible here because it is just going into this sequential manner, right? So now here there are only two messages coming into picture: election E to announce an election, and it will be this election E message will be sent with a token. Token is the process ID. Whichever process node is going to initiate or it is going to send that election message, it is also going to send its own process ID with that election message. Okay, and at the end, whenever the new coordinator is elected, that will be denoted by coordinator, that is capital C. Okay, so now you can check here. Initially, again, 0, 1, 2, 3, 4, 5, 6, all these 6 participating nodes are there or processes are there. And 6 is the earlier coordinator because with highest process number ID. But now 6 has failed or crashed. So you can see the node 2 say who is going to initiate, because it comes to know about 6 is not responding again. Same as your Bully algorithm. So 2 is the node which comes to know that 6 is not responding. Obviously 2 will start the election message. It's not compulsory कि 2, अगर 0 को पता चला 1 को, जिसको पता चल रहा है वो शुरू करेगा. 2 is going to start the election. Obviously when 2 is initiated, 2 is going to start, so it will send the message E to 3 with its own process ID, that is a token here, with its own process ID, that is 2. You can see in square brackets. Now from 3, now the election message will be sent to 4. जिसको connected है उसको ही जाएगा 4. So along with 2, what will be added now? 3. Then from 4 to 5, through 2, 3, 4. From 5 to 0, it is 2, 3, 4, 5. एक एक add होता जा रहा है, you know. From 0 to 1, 23450, and from 1 to 2 it is 234501. So from 234501, what 2 will come to know? Jab 2 will receive this message, 2 will come to know that whichever message I have initiated or started from 2, it is the same message which has traveled over the entire ring, and now it has come to me. Because 2 के आगे क्या क्या append हुआ? 3 4 5 0 1, right? So now what 2 will do as an initiator job, that 2 will see the node or the process with highest process number or ID, that is 5 here. As 5 is the process with highest ID or process number, 5 will be declared as what? 5 will be declared as a new coordinator, and that will be announced to all the other processes or participating entities. That's it. So now it is going to take place here in token ring. That is the only essence of this token ring algorithm. It is token ring kind of structure, one after another only, not at the same time, taking the process numbers IDs from all the participating process like bully. It is not like that. Here in token ring, it will just move into the circular or cyclic structure only. Now this is simple comparison. Again, comparison sort of thing is not going to be asked separately, but it will be a short note on election algorithms, short note on Bully or tokening algorithm. So there itself you can add this comparison where Bully algorithm for best case n minus 2 messages, for worst case big O of n square. In ring algorithm 3n minus 1 messages in worst case and n minus 1 in, you can say, a best case, where each and every message is going to be sent to the successor. Okay, so this is one, you can say, example explained for election algorithms. Now I'll just switch to one more example here. Yeah. So in this election algorithm, again, you can just go through this. What is the goal of election algorithm that we have seen? Again, these two algorithms, ring and bully. So this is very nicely explained. Each and every diagram, each and every iteration, I can say, is represented here with the diagram. That's why I'm showing you this example. In PPT, only few diagrams are drawn and algorithm is explained. So just to make you aware about the each and every step of the algorithm, I'm just showing you this example. So now we will start with token ring. Just now I've told you token ring, it will move in a ring structure. So initially all 6 participating processes are there, 6 is failed. As 6 is failed, what you can see 3 will do, 3 notices that 6 is not responding, so 3 will start with the election. So when it is going to send that election message to the next neighboring or connected node, that is 5, it is going to send a token along with that election message, and that token is its own process number or ID, that is 3. When it reaches to 5, from 5 it will go to P0. So obviously उस 3 में क्या और append होगा 3 5. You can see here. You can read it afterwards properly. From P0 to P1, what will be there now? 350. From P1 to P4, it will be 3501. From P4 to P3, it will be 35014. So 3 has started and it has received this message as 35014. 3 will come to know मैंने जो भेजा था वही मेरे पास आया है वापस with all these process IDs appended to it, right? Now what 3 will do as an initiator? 3 has started the elections, 3 becomes initiator, right? 3 is going to check which process is having the highest process number, that is 5. So as 5 is the highest process number or ID, obviously 5 is declared as a new coordinator. 5 is the leader now, right? Now, as 5 is a leader, it will be, again, 5 is going to start with the process. This 5 is a leader will be notified to all. Okay, then 5 will start the process, so on, so on, so on, so on, till it crashes, and then again the method goes with the other one, right? Otherwise, it will be continued in a ring structure. Now, Bully election algorithm, again, we are having 6 processes. All are connected to each other. Why? Because we are going to take the process numbers or IDs when the election is called, right? Now, process 6 fails. You can see this is process 6, it fails. Again, process 3, it comes to know about that 6 is not responding. So, 3 will call the election, but 3 will call the election. That election message will be only sent to 4, 5, 6, जिनका process numbers 3 IDs 3 से ज़्यादा है, right? जिनका process numbers या IDs 3 से ज़्यादा है, उनके पास ही election message जाएगा, right? From there, what 4 and 5 will do, because 6 is not responding, 6 is still under that failure mode, right? So as 6 is not responding, what 4 and 5 will do, 4 and 5 will say to 3 that now you are bully. So from here we will take the charge. So you are out of this election process. So P3 is kept aside or crashed or killed. Okay, and now P4 and 5 are there. So obviously 4 will start the election. As 4 will start the election, 4 will send the message to P5 and P6 जो उससे बड़ा है ID number. So P5 and P6. Again, P6 will not respond because it is still in the failure mode. So P5, what P5 will do? Now P5 will make P4 as bully and it will kill or crash it. Okay, or it will kept it aside, not crash, kept it aside, and now only P5 is left. So now P5 will send the election message, obviously only to P6 because P6 is having the greater or larger ID than him, right? After that, again, P6 is not responding. So P5 comes to know I am the only one left and I am the only coordinator now. So P5 will declare that I am the leader in that happy mood, and all other participating nodes will come to know that now the new elected coordinator is P5. Again, the process will be continued till P5 crashes. Okay, so these are the examples which you have to implement in LP1. So one assignment says that you have to implement election algorithms, that is token ring and bully. So these algorithms as in step by step, I've explained you the example. This is the algorithm itself. Now you have to implement it in Java, that is preferred by me. Okay, still some more videos I'll try to take out. Other than this video, I'll try to give you some other videos from Edureka that will be uploaded in the other section, LP1 subject section on Bodhi tree. And these videos will come under whichever I have explained. These videos will come under this DS section, like theory lectures, right? So these videos plus other videos which I'm going to give you in LP1, all those videos you have to study and start implementation of bully and token ring algorithm, election algorithms. Okay. So that's all with this bully and token ring for theory as well as for practical purpose. Okay. Thank you.